to all of you. My name is Gaurav Sharma from MBI with my team member Akshay. Today we are presenting our quality improvement project of elimination of soft and cracked problem on by press machine.
Crack and soft both are the top for contributing in our internal rejection. If it is not caught in next operation and get dispatched to the customer, then the performance of lighting gets reduced and becomes customer complaint. In this graph, you can see that we have received two concerns from the customer in the last 2 years regarding this issue. After that, when we made the Pareto analysis chart and arranged the problem in descending order, then we found that crack and soft is the highest contributor in our internal rejection, that is 33.8%. Our project objective is to achieve the target of zero customer complaint and to reduce the crack and soft problem by 80% from its current level. In this shows that you can see the project matrix that in the year of 2023 we had a customer complaint regarding this issue and our target is zero. We had 2.53% internal rejection and our target is less than or equal to 2%. We had 0.83% rejection due to crack and soft and our target is to reduce by 80%. We had 0.11% crack material hold and block audit due to this issue and our target is zero. In this graph, you can see the internal rejection trend that in the month of June 2023, we had 2.54% internal rejection in which the contribution of crack and soft problem is 0.83%.
We did brainstorming among with the team member and accordingly cause and effect diagram was made to identify all probable causes. And after validation, we found temperature law is responsible for crack and soft problem. This is the validation method how we conclude temperature law is responsible for soft and cracked problem. After this, we did YY analysis for soft and cracked problem and we found temperature was in loop in tool cavity. Why? Because heater is not touching tool surface. Why? Because there is excess clearance between tool and cavity. Why? Because heater outer diameter is less. And see in the picture, there is big gap between heater outer diameter and tool hole. When we check heater size, that is 15.82 and hole size 18.11. So there is 2.11 mm clearance. To prevent this problem, we increase heater size from 15.8 mm to 18 mm and reduce clearance from 2 mm to 0.2 mm.
After the heater outer diameter increased, we checked the effectiveness and found that with this implementation we could able to reduce our internal rejection from 2.54% to 2.24% and crack and soft rejection from 0.83% to 0.42%. But it was the only 50% improvement. So again we did YY analysis and take actions accordingly.
In this YY analysis, we found there is still variation in temperature. Why? Because temperature is not increasing. Why? Because temperature is consistent at lower side. Why? Because heater wattage is less. Heater wattage is less, so temperature is not achieved at desirable level. As you can see this graph, first we set temperature in machine 150 degrees Celsius and we achieve temperature in tool cavity was 135 degrees Celsius. Then we increase set temperature in machine from 150 to 155 degrees Celsius and we achieve temperature in tool cavity was 135 degrees Celsius. Further we increase temperature in machine from 155 degrees Celsius to 160 degrees Celsius and we achieve temperature in tool cavity was 136 degrees Celsius. We notice in spite of increasing temperature in our machine, temperature is hardly increased in our tool and cavity. So we conclude this is heater wattage.
To solve this problem, we increased the heater wattage from 500 watt to 800 watt. As you can see in this previous graph, that when we set temperature on 155 degrees Celsius, we got our actual temperature consistently at the lower side. And after the heater wattage increased, when we set temperature on 155 degrees Celsius, we got our actual temperature near to our set temperature. And thus our problem has been eliminated. After the heater wattage increased, again we checked our effectiveness and found that from this implementation, we could able to reduce our internal rejection from 2.24% to 2.21% and crack and soft rejection from 0.42% to 0.29%. But still we did not get our target. So again we did YY analysis and take actions accordingly.
Again we did YY analysis and found there is still variation in temperature. Why? Because heaters are moving forward and backward during machine running. Why? Because heaters are free to move. Why? Because there is no provision to lock the heater. As you can see in the pictures, heaters are moving forward and backward during machine running. So heaters are moving backward and there is no contact between tool cavity and heater. As a resulting temperature was low.
As you can see in this before picture that there is no provision to prevent the heater movement. Heaters was moving forward and backward. To solve this problem, we provided a thread bolt at the end of the heater and locked them with nut and washers. So heat of net problem has been eliminated. After that, we checked the effectiveness and found that we reached near to the target but not fully achieved. So again we did YY analysis to achieve our target.
In this YY analysis, we found sometimes heaters are not working. Why? Because heaters are short frequently. Why? Because mix and saffron is falling on heater wires. As you can see in the pictures, mix and saffron is falling on heater wires and they getting short. To prevent this, we provide a cover on cooling side. Now prevent from mixer and saffron. And along with this heater connection done through wiring and mix falling on this. Now we providing a male and female connector on machining time. It's also reduce our changeover time.
After all the implementations, we find that our internal rejection is 1.72%. Earlier it was 2.54% when we started our project. Crack and soft rejection is 0.11%. Earlier it was 0.83%, and our target has been achieved. If we talk about the tangible benefits, then we can say that from these all implementations, we could able to reduce our internal rejection from 2.97% to 1.72%. There is no particular hold at top due to this issue, and there is no customer complaint in the last 9 months regarding this issue. There are some additional benefits also. Our tool changeover time has been reduced from 4 hours to 1 hour. Machine breakdown reduced from 1.26% to 0.13%, and also our production from 72 pieces per hour to 84 pieces per hour. Our total savings in INR is 36 lakhs per annum. After that, we have updated all our control documents as our control plan, FMEA, request raised for best practice also, and it has been standardized and controlled by new SAP code.
Thank you. Question and suggestions are welcome.